This is Note-Taking Guide 4.3 for Math 2. We're going to solve equations in one variable. So over here it tells us that our steps for this two-step equation we're going to do is to isolate the variable. And it tells you the steps on how to do that. You're going to isolate the variable by subtraction, and then you're going to isolate the variable by division. So let's take a look at that first problem. In order to isolate the variable, we're going to have to get rid of the 9 first. So we're going to subtract the 9 to the other side. We're going to have 2x equals 26, because 35 minus 9 is 26. And then we're still just going to isolate the variable there. In order to isolate the variable, we're going to have to get rid of the 2 on the x. The 2 is multiplied, so we're going to divide both sides by 2 and get x equals 13. Now, if I ever wanted to know if I were doing that correctly, I could just take this number and substitute it back up here into the top to make sure that it works. Problem 2 here, isolate the variable. I like to just remember I got to get this by itself, so the first thing I need to move is add that 3 over to the other side. On this side it cancels, which is why I did it. And then on this side I have negative 13 plus 3, which is a negative 10. Divide both sides by 5, because 5 times x, I need to get rid of that 5. And then I'm going to just have x on this side and negative 2 on the other side from negative 10 divided by 5. This time we're going to do a greater than or less than problem. It works exactly the same way. We do have one rule we need to worry about when we divide by a negative number or multiply by a negative number. We have to flip the inequality sign, but let's just wait and see if we need to do it on this one. So I'm going to isolate my variable again. In order to do that, I have to get rid of this 12. That 12 is positive, so I'm going to subtract it to the other side. Cancels over here like I wanted it to, and then I'd have 7x is greater than or equal to whatever 75 minus 12 is, which is 63. Again, still going to isolate that variable. That variable has 7 times x on it. To get rid of multiply, we're going to divide. 7 divided by 7 is 1x. Because I divided by a positive, I get to keep that sign the same way, and then 63 divided by 7 is 9. Here's another inequality. We're going to isolate the variable again. In order to do that, I first have to add the 15 to the other side. When I add the 15 to the other side, I'm going to have a negative 6x on this side because the 15's cancel. I'm going to keep the inequality sign the same direction and do 69 plus 15, which is 84. Then I'm going to have to get rid of that negative 6 on the variable, so I'm going to have to divide both sides by a negative 6. Now right here, when I divide by a negative 6, I have to remember that anytime I divide by a negative, I have to flip my inequality sign. So my x is going to be here, from the 6 divided by 6 is going to be just the 1. I have to flip this inequality sign the wrong direction, and then I'm going to do 84 divided by negative 6, and I'm going to get negative 14 for my solution. So again, anytime we multiply or divide by a negative 1 when we're using inequalities, we're going to flip that sign around. Alright, another example here. This is the equal sign, but we need to isolate the variable, so the negative 4x first. In order to do that, I have to get rid of the 15. I'm going to subtract it to the other side, so I'm left with a negative 4x. And over here it's going to be equal to a positive 16. Divide both sides by a negative 4 because it was multiplied. It cancels over here to 1x, and over here I get negative 4. Because it was an equal sign, I didn't have to worry about doing anything to the sign. I just had to do my arithmetic. Here's another one. Still going to isolate this variable. Right away, that variable looks like it's attached to the 6, so I need to get it by itself before I can do anything else. So I'm going to subtract this 5 to the other side. So I have x over 6. The 5's are gone, and I'll have a negative 2 on the other side. Now this is one that we haven't seen before yet. The 6 is on the bottom of the fraction, which means we're dividing by 6. In order to get rid of division by 6, I have to multiply both sides by 6. So times both sides by 6. It cancels over here because 6 divided by 6 is 1. So I'm left with just x. And on this side I get a negative 12. Here's another problem that looks very similar to that. I need to isolate this x and the 7, so I'm going to add the 13 over to the other side. And I get x over negative 7 equals a positive 8 because of the negative 5 plus 13. Over here again I'm dividing by a negative 7, so in order to get rid of divide by negative 7, I'm going to times by negative 7. So over here it cancels to 1, and on this side I get negative 56. The next kind of problem that we're going to do today is to write each sentence as an equation or inequality. It says the difference of 8 and a number is 14. So when we're subtracting here, if I said the difference of 4 and 2, then you would write it that same way as you would there. So the difference of 8 and a number is 14. This next one says 9 plus the product of 3 and a number. So 9 plus the product of 3 and a number is greater than 30, so bigger than 30. And then the third one here says the quotient of a number and 8 added to 15 is 8. So the quotient of a number and 8, so a number divided by 8, added to 15 is 8. Thanks for watching this note-taking guide.